Hello Chem Peeps. Today we're going to talk a series of 3 videos where I'm talking about phase diagrams. First video I'm just going to explain what a phase diagram is, and then in the second 2 I will do examples of interpreting data from them and answering questions. So look for the following 2 videos from this one that I'm doing. So a phase diagram basically shows the 3 phases of matter for a substance. The phase diagram that I have on the right here on the screen is a generic one. It's not identified as any particular substance. My axes are not labeled properly. So on this axis, we're seeing an increase in temperature. Okay, and then on the y-axis, we have pressure increasing as we go up. So as we look here, you can see we have our 3 phases of matter: solid, liquid, and gas. And we have different labels on here. So you can see from point C to A, we have an interface here between solids and gases. And solids can go directly to gases, and gases can go directly to solids given the correct pressure and temperature. And that phase change for that is sublimation and deposition. So when I have like snow that just seems to like disappear without any puddles, what's going on is the solid state of snow is becoming a vapor. It's sublimation. And deposition is the opposite, something from the gaseous stage. For example, when you come out in the morning after the temperature has dropped, you might have crunchy grass. Where did that frozen grass come from? Well, the moisture in the air deposits directly from the gaseous stage into the solid phase. That's called deposition and sublimation. Then along the axis, point A all the way up to B, we have an interface between liquid and gas. And so the change in phase between liquid and gas is vaporization if it goes liquid to gas, and condensation if it goes from gas back to liquid. So when you have like an icy glass of lemonade and all of a sudden you see all this moisture dripping on the outside of the glass, that is not coming from inside the glass. That's coming from the atmosphere touching the glass. The moisture in our air in the gaseous state comes in contact with that cold glass and it condenses on the outside. Likewise, the vaporization, if I have a liquid and it goes into the gaseous state, that's called vaporization. Then along A to D, what is going on here? A to D, we have an interface between solid and liquid. And so the phase change there is melting and freezing. So if you look to the left here, and we're going to just quickly go over it. We've already talked about what a phase diagram is and the sequence from solid to liquid to gas. And then we have going the opposite way from gas to liquid to solid. The process of going from solid to liquid to gas is what we call endothermic. In other words, for that phase to change, we must put energy into the substance so that it has enough to speed the molecules up and change phase. If we look at the other direction, it's exothermic. In other words, to go from the gas back to the liquid, back to the solid, we must take energy out of the matter so that it slows down and is able to make that change of state. So here we just have the different phases or phase changes that we talked about on the graph, and whether it's endo or exothermic. This will come into play when I talk about heating curves, but we're going to stick with phase diagrams right now. So catch me on my next videos with examples of interpreting those graphs, the phase diagram graphs, on TikTok or YouTube at Kim's Chem Chats. Talk to you later.